Hello everyone, my name is Aishwarya Shetty. I am here to present my Computer Architecture IAC, that is MIPS Assembly Code Layout and Basic Codes. Now, introduction to MIPS Assembly Language. MIPS, that is Microprocessor Without Interlocked Pipeline Stages, is a popular assembly language used in computer architecture. It is a RISC, that is reduced instruction set computer architecture, that allows for efficient execution of instructions. MIPS uses a simple and clean design that emphasizes a small set of instructions. Now we will look for the MIPS assembly code structure. A typical MIPS assembly program consists of following sections, that is data section, which declares and initializes data variables. Text section contains the actual instructions that the CPU will execute. Third is stack section, which is used for dynamic memory allocation during program execution. Now the MIPS 32 assembly code layout is as shown below, that is .text, which is the code section, .global main, starting point must be global, then comes main section where user program code goes here, .data, that is data section, and where the program data goes. Now we come to MIPS instruction formats, that is they are classified into three formats, that is R type, register type, used for arithmetic and logical operations. Second, I type, that is immediate operation, used for instructions with constant and memory access. Third is J type, that is jump, used for jump instructions to change the program flow. Now we will see some basic MIPS instructions. First, add. This adds two registers and stores the result in a register. Second, sub, that is the subtracts one register from another. LW, that is loads a word from memory into a register. Fourth, SW, that is stores a word from the register into the memory. J jumps to a specified address in the program. Now we will see the basic examples of MIPS program, that is add two numbers in memory and store the result in the next location. As we can see the code given below, .text is the directive that indicates the following part of the code is for program's instructions. Second, .global main, this declares main as the global symbol. Then comes the main, that is the start of the main function in which the program is written. The LA $T0 value, it means that LA load address loads the address of the value array defined into register T0. LW, that is load word, loads the first element of the value array into register T1. Next, load $T2 4 into $T0. This instruction loads the second element of the value array into register T2, and for T0 indicates that it loads the element at an offset of 4 bytes from the address in $T0. Next is add T3, $T3, $T1 and $T2. This adds the contents of registers T1 and T2, that is 50 plus 30, storing the result 80 into register T3. And last is SW, that is store value, and that stores the value in T3 which is 80 and back into the memory at location 8 into T0. Dot value is to dot word 50 30 0. This defines an array of 3 words, 32-bit integers. The first word is 50, the second is 30 and the third is 0. These values are stored in contiguous memory. Example, that is add two constant numbers specified as immediate data and store the result in a register. Here the text global main remains the same, and in main it is add T2 0 into 2A. That is, T1 is the destination register, 0 is a register that always holds the value 0, and 0 into 2A, that is a particular value, is the hexadecimal value for 42 in decimal. This means the instruction essentially loads the immediate value 42 into register T1 by adding 0 and 42 together. Now in next example, that is, read two numbers from the keyboard and print the sum. Here it is user defined input, so we use string, and for the string we use ASCII values, that is, enter first number, enter second number, and the sum is. The code remains same, but this is called, it executes the system call to print the string in A0. Likewise, sub, load word and store word instructions are performed. I conclude this ISC. Thank you.